Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 17, 2025, about 4 days ago. The standout is simple and bold. This paper introduces the first standardized anonymized benchmark for predicting founder success in venture capital and shows several large language models beating human baselines. The paper is titled VCBench, Benchmarking LLMs in Venture Capital, and as we will see later, the implications for fair, privacy-preserving evaluation are significant. In short, the dataset spans 9,000 founders with a 9% success rate and enables reproducible testing under real uncertainty. On X, reactions highlight that models outperform many investors, cite the 9,000 founder dataset and 1.9% market baseline, and debate implications for venture jobs, with one post showing strong engagement at 166 likes. Alright, the previous segment framed why a privacy-preserving benchmark matters. Figure 1 presents model performance, plotting precision on the x-axis against f0.5 on the y-axis, which weights precision more than recall because false positives are costly in venture decisions. GPT-4o sits highest on f0.5 around mid-20s, while DeepSeek v3 reaches the far right with the strongest precision near 60%, but a lower f0.5. Human baselines cluster low left, and several models clearly exceed them. So, while the previous figure compared model performance, Table 1 contrasts benchmarks on how they handle messy real-world data. The table highlights 4 functions that matter, because they determine whether models face the true prediction task: filtering, standardization, coverage improvement, and anonymization. VCBench is the only one that checks all 4 boxes, which signals a focus on both data quality and privacy. Other popular benchmarks cover at most 1 or 2 of these steps. The previous table contrasted benchmark capabilities. Figure 2 shows the data cleaning pipeline, which starts with raw JSON, applies data coverage improvement, then performs format standardization and filtering, and finally runs anonymization with bucketing and feature preservation. The top row demonstrates how gaps get filled and labels become consistent, so irregular entries do not leak through. The bottom row illustrates the privacy pass that replaces identifiers with clustered industries and QS rankings while keeping predictive structure intact. While the previous figure detailed model accuracy trade-offs, Table 5 summarizes cost per 1 million tokens for input and output, and latency, so it clarifies operational efficiency alongside quality. GPT-4o Mini offers low cost with around 3 seconds latency, while GPT-5 is the fastest at roughly 1.5 seconds. DeepSeek v3 is notably inexpensive per token, but runs slower than GPT-4o Mini. These numbers matter because venture workflows prize both affordability and quick turnaround when screening many founders. Alright, the previous cost table covered efficiency trade-offs. Table 4 reports average precision, recall, and f0.5 across 6 folds, so it directly ranks models for venture decisions where precision matters more. GPT-4o leads on f0.5 at 25.1, which reflects balanced precision at 29.1 with modest recall. DeepSeek v3 tops precision at 59.1, but posts very low recall and the lowest f0.5. Gemini 2.5 Flash delivers the highest recall at 69.1, but lags on precision. Wrapping up, 2 takeaways stand out. The benchmark makes venture predictions reproducible and privacy-preserving at scale, and leading models already surpass human baselines, with GPT-4o best on f0.5 and DeepSeek v3 strongest on precision. The broader implication is clearer, fairer evaluation for real decision workflows. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.